Hi, I want to take a look at an example of the ideal gas law. Now in chemistry, we often talk about multiple ideal gas law, Boyle's law, other folks' laws. I can never sort them out because in physics they're all the same law. Pressure times volume is equal to the number of things we're dealing with, either things or moles, a constant depending on whether we're counting in things and moles, times the temperature. But if you seal a container, then what you end up with is pressure times volume over temperature is equal to a constant. So for any sealed ideal gas, the initial pressure times volume over temperature will be equal to the final pressure times volume over temperature. And the three ideal gas laws from chemistry come from holding one of those other pieces constant. So say you check your tire pressure when it's 34 Fahrenheit in the morning and your pressure gauge reads 27.0 psi. You come back to it later in the afternoon when the temperature of the tire is 58.0 Fahrenheit. What's your pressure gauge going to register? Now, a couple of thoughts. Car tire rubber isn't very stretchy at all, so the volume's going to remain roughly constant. Now, temperature absolutely positively has to be in an absolute scale, so that means we should convert any temperatures over to Kelvin, and we have to use an absolute pressure. Tire pressure gauges record gauge pressure, and the absolute pressure is going to be the gauge pressure, 27.0 psi, plus the pressure of 1 atmosphere. So if we're working in psi, we would add 14.7 psi. So the absolute pressure in the tire is going to be 41.7 psi initially. Now, to convert our temperature from Fahrenheit to Kelvin, we'll make a stopover in Celsius. So to convert to Celsius, the first thing we do is subtract off 32 Fahrenheit to figure out how many Fahrenheit we are above the freezing point of water. So 34 minus 32 means we're 2 Fahrenheit above the freezing point, times 5 Celsius for every 9 Fahrenheit means our temperature is 1.11 Celsius. Since our temperature in Kelvin is 273.15 plus our temperature in Celsius, the absolute temperature is going to be 274.26 Kelvin. Now, later in the day, we apply the same process. 28 minus 32 tells us that we are 26 Fahrenheit above freezing, or 14.44 Celsius, which is 287.59 Kelvin. Now, since our volume is constant, our initial pressure over our initial temperature will be our final pressure over our final temperature. So our final pressure is our initial pressure, 41.7 psi, times our final temperature, 287.59 Kelvin, divided by our initial temperature, 274.26 Kelvin, and that gives me a pressure of 43.7 psi. But your pressure gauge is going to give you the gauge pressure. So you would have to subtract off the pressure of the atmosphere, subtract off 14.7 psi, and your pressure gauge is going to tell you the tire pressure is 29.0 psi. Thanks for watching.